Hello class, this is lesson 8-3 and 8-4 about 0, negative, and integer exponents. So to begin, let's look at this list of expressions. 2 to the 4th power is 16, 2 cubed is 8, 2 squared is 4, and 2 to the 1st power is 2. So let's look at the pattern that we have going on. We're dividing by 2, we're dividing by 2, we're dividing by 2, and so what do you think would happen for 2 to the 0 power? Well, we would divide by 2 again, which would equal 1. So our first property is that any number to the 0 exponent is equal to the integer 1. All right, let's go ahead and keep on looking at this pattern. If I divide by 2, now I have 1/2. So 2 to the negative 1 power is 1/2. If I divide by 2 again, I have 1/4, which is the same as 1 over 2 squared. If I divide by 2 again, I get 1/8, which is the same as 1 over 2 cubed. And if I divide by 2 again, following that pattern, I get 1 over 16, which is the same as 1 over 2 to the 4th. So any number to a negative exponent is the same as 1 over that number to the positive exponent. So let's put these into practice. We're going to simplify these expressions and leave our answer with only positive exponents. So first thing that I notice is I have 56 in the numerator and I have 8 in the denominator, which can simplify to just 7 on the top. And then on the bottom, g to the 0 power is 1, h to the 0 power is 1, and j to the 0 power is 1. So really, this expression simplifies to 7g squared h j to the 11th power. And that's it. So pretty straightforward for this first example. Our next example, I first want to make all of my negative exponents to be positive. So that means that b to the negative 4th exponent is going to go down below and then it will be positive. And my c to the negative 2 exponent needs to go up above and now that will be positive. So rewriting this, I have a cubed c squared all over b to the 4th, and it can't be simplified anymore. So that is my final answer. All right, let's move on. This time I have 42 divided by 14, so that leaves me with just a 3 in the numerator. I have a negative exponent on top, so I'm going to move that down below. And I have another negative exponent on top, which I will move down below. And then I have a negative exponent on the bottom, and I'm going to move that up above. So let's go ahead and just rewrite this with positive exponents. I have 3, and I have that u cubed, and then I'm also having another u cubed from the bottom. Now in the denominator, I already have r squared, and I'm moving an r squared down below, as well as t to the 6th power down below. So now that I have positive exponents, let's clean this up. On the top, we have 3u to the 6th power over r to the 4th power, t to the 6th power, and we're done. All right, and now moving on to our final example here, we can simplify the 3 and the negative 36 to just leave us with negative 12 on the bottom. The m to the negative 3 exponent is going to move to the bottom. That p to the 0 power will cancel out, and then the p to the negative 4 exponent we will move to the top. So rewriting this, I still have n squared on the top, and I'm moving that p to the 4th power to the top. And underneath, I have negative 12 m cubed. I move an m cubed to the bottom, and I still have an n on the bottom as well. So now we can go ahead and see if we can clean this up. I have n squared on top and an n on the bottom, so I can go ahead and simplify those to only be left with an n on the top, followed by p to the 4th power on top. Underneath, I have negative 12 m to the 6th power, and that's it. So that is our final expression in simplified form. All right, let's go ahead and move on now to rational exponents. Remember, the word rational means something similar to a fraction. So if I have a to the fraction 1/2, that is the same as the square root of a. So let's look at our first two examples here. Some of these examples have exponents and some are already in radical form. But looking at the first one, 25 to the 1/2 exponent is the same as the square root of 25, which is 5. Our next example is already in radical form. The square root of 4 is 2, and the square root of p squared is p. So our answer is 2p. Now, the next rule that I want to teach you is that you could have a number to any fraction for an exponent. For example, it could be the number a to 1 over n. Okay, and so if that is the case, then that means that you are not going to take the square root, you're going to take the nth root of that number. So for instance, you might be taking the cube root or the fourth root. So in our next example, we have 100,000 to the 1/5 exponent. So this means I'm going to take the fifth root of 100,000. So I'm trying to find one number times itself 5 times to get me 100,000. Well, that's the same as 10 times 10 times 10 times 10 times 10. So that means that the fifth root of 100,000 is 10. All right, our next example is to take the fourth root of 625. So we need to think, oh, how do I get that? Well, that's the same as 25 times 25, which is the same as 5 times 5 times 5 times 5. So since there are 4 of those, the fourth root of 625 is just the integer 5. Moving on now, we have 81 over 256 to the 1/4 power. So this is the same as the fourth root of the fraction 81 over 256. And that's something that we can break up as just the numerator, the fourth root of 81, over the fourth root of 256. And so again, these are things that you probably don't know by heart, but for 81, I know that that's 9 times 9, which is 3 times 3 times 3 times 3. And I know 256 is 16 times 16, which is 4 times 4 times 4 times 4, which in the end will simplify to the fraction 3/4. All right, let's move on to this final example here. We're going to take the cube root of 64m to the 6th power. So 64 is 4 times 4 times 4, and m to the 6th power is m squared times m squared times m squared. So when I take the cube root, I'm left with 4m squared, and that's it. All right, to wrap up this lesson, I have one final rule for us with exponents. And again, it's with a fraction exponent, but it could be any fraction, some number over another number. When that's the case, you still are going to take the nth root of that number, so put that on the outside, but we're going to attach that m exponent to our number a. A second way that you could do this is, again, by taking the nth root of a, and then at the end, putting that to the m exponent. So I'm going to show you both of these versions right now. Our first example is 32 to the 2/5 exponent. So why don't we try the first scenario? We're going to take the fifth root of 32 squared, okay? So let's figure out 32 squared. When I multiply it by itself, I get 1,024. And just by doing this for a while, I know that that's 4 times 4 times 4 times 4 times 4. And so the fifth root of that is just the number 4, okay? My preference is actually using the second method from up above. So for our next one, we have 729 to the 5/6 exponent, which means we're going to take the sixth root of 729. And once we figure that out, we're going to put it to the 5th power, okay? So 729 is the same as 9 times 9 times 9, which is 3 times 3 times 3 times 3 times 3 times 3. And the 6th root of that is just 3. And 3 to the 5th power now is what we need to finish to find our final answer, which is 243. Our final example now is 36 over 49 to the 3/2 exponent. So again, this is telling us that we're going to take the square root of the fraction 36 over 49, and once we have that, we're going to cube it. So the square root of 36 is 6, the square root of 49 is 7. So now let's go ahead and cube this fraction. 6 cubed is going to give us 216, and 7 cubed is 343. And that is our final answer. So we learned a lot of new things about exponents today. I hope that it made sense to you, but as always, please let me know if you have any questions when you come into class.